Hi everyone again, and welcome to video number 2. Because we already know the Dornheim Segmenter program, we will now see some features and tools and how to apply them to obtain our objectives according to the project that we have. Today we will know a very powerful feature of this program, the interpolation. For this we will make a 3D model of a healthy liver from a contrast-enhanced abdominal CT scan. I personally prefer to do this task in the axial plane. In the segmentation tools on the right, we select Paint. Here we can see several brush options. And we also have the interpolation option activated, which is what we want to show and that I consider very important, not only because it is very useful and precise, but also because it is immediate. So let's make the liver segmentation. We choose a plane in the middle of the organ and draw a mask by a free stroke, pressing Shift. Then we go to some images below and draw another mask, and when we finish it, we will see that immediately the planes in between have been interpolated. We move again to another image and draw another mask. As you can see, the interpolated planes are very intuitive. We can see that the masks that we draw have a different brightness compared to the ones that have been interpolated, so if needed we can further modify those that we did. And that way we will obtain this organ by drawing only a few but correctly selected planes. If we identify that any of the interpolated planes is not exactly what we want, we can correct it, and again automatically the rest of the interpolated planes will be corrected. It is also possible to divide the interpolation into two different structures, as for example, in this case we see that the liver lobes have separated into 2 or even 3 parts, and the software will interpolate them correctly. If we see any interpolated plane that has surpassed the edge of the structure, we can correct it by pressing Ctrl and Shift and adjusting the edge. Once we have finished, we accept and name our segmentation, and now we can convert it to a 3D model. We wait for the task to be completed, and this is the model that we obtain. As we can see in the 3D view, we have a liver of normal morphology, and we can correlate it with the CT planes to evaluate its accuracy or take some snapshot if we want. This 3D model can be exported in different formats, for example in OBJ if we want to use it for visualization softwares, or in STL if our goal is 3D printing. Another example of a segmented structure by using this technique is the abdominopelvic cavity, from the diaphragm to the pelvis, as you can see here. With this technique you can get to segment virtually any organ or structure, but only using this technique it can be a very laborious job. So in order to have a segmentation protocol with more efficient workflow, we will have to use this technique in combination with others that we will see in the following videos. So that's almost the end of video number 2 of this tutorial.